Welcome to Competitive Engineering. This is Fluid Mechanics lecture video number 2. In the previous video we discussed about various properties of fluids. In this video we are going to discuss about viscosity of the fluid. Before that, these are some useful instructions. You can change the video quality at the bottom right corner, and if the video is found very slow you can increase the speed also. Please don't post unwanted comments. If the video is found useful, please support us by sharing and feel free to ask any questions and requests for videos. So we are going to viscosity. Viscosity is the property of the fluid which offers resistance to flow. Actually, before discussing viscosity, we have to discuss the property called cohesive force. Cohesive force is the force of attraction between the similar molecules. So when a fluid is flowing which is having a velocity u infinity at a far distance from the surface, when it is flowing above a horizontal stationary plate or through a pipe or something, so the fluid layer which is at the bottom, which is in contact with the stationary plate, will reach to zero velocity. So the velocity layer just above that, because of this force of adhesion, that is attraction between the similar molecules, it will pull the molecule to come to zero velocity. So in the similar way, when going up, the velocity increases, because at the topmost level the velocity will be u infinity, and when just below that it will be less than u infinity. So if we take a portion from the fluid flow, we can take one fluid velocity as u, and at a distance of dy, means vertical distance dy, the velocity is u plus du of the fluid layer. So in that case, this is the condition, that is the bottom fluid layer is having velocity u and the top fluid layer is having u plus du, and the distance between the fluid layers is dy. There is a law called Newton's law of viscosity, which measures the shear force that develops between the fluid layers. So Newton's law of viscosity, which is a very important concept in all the competitive exam, which states that the shear stress between the fluid layer is proportional to the velocity gradient. So that is, shear stress is denoted as tau, is proportional to du by dy. Du by dy is the velocity gradient, that is du is the change in velocity. The top layer is having u plus du velocity and the bottom layer is having u velocity. The difference in velocity is du, divided by dy is the distance, vertical distance. So du by dy is called velocity gradient. In other terms, shear stress is proportional to shear strain rate. That is also one form of other form of Newton's law of viscosity. So in problems we will be using this concept, shear stress is proportional to velocity gradient, that is tau is proportional to du by dy. We will be coming back to Newton's law of viscosity in the same lecture after some time. So we can plot it Newton's law of viscosity like this, that is tau is in the y-axis and du by dy, that is the velocity gradient in the x-axis, so it will be a straight line. Tau is proportional to du by dy. So shear stress is the shear force divided by area, that is F by A. So this tau proportional to du by dy can be written in a equality form, that is tau is equal to mu into du by dy. Here we introduced a constant of proportionality called mu, and it's called coefficient of viscosity, specifically coefficient of dynamic viscosity. Okay, so mu is the constant that we are introduced here. So mu is the dynamic viscosity, unit is Newton second per meter square. Newton per meter square, that we can write as Pascal, the unit of pressure, so we can write it as Pascal second. In some problem it will be given as Pascal second, mu in Pascal second, so you should understand that. Or in CGS unit it is Poise. One Poise is equal to 1 dyne second per centimeter square. So in some problems the viscosity will be given in Poises, you have to convert it to the SI system. So 1 Poise equal to 0.1 Newton second per meter square. So if Poise value in Poise is given, just multiply it with 0.1, then you will get it in Pascal second or Newton second per meter square. There is one more viscosity term called kinematic viscosity, it is denoted as nu. So kinematic viscosity is removing the mass mass term in the viscosity by dividing the dynamic viscosity with the density, that is nu is equal to mu by rho, where rho is the density. So unit is meter square per second or stocks in CGS. So stocks is equal to 10 raised to minus 4 meter square per second. One stock is equal to, so in some problem it will kinematic viscosity will be given in stocks, so you have to convert it to 10 raised to minus 4, that is multiplied with the 10 raised to minus 4. Viscosity of water is generally taken as 1 centipoise. Just note this, in some problems if water is used in the liquid, viscosity may not be given. In that case you have to use 1 centipoise, that is 1 into 10 raised to minus 2 poise. Then again you have to multiply with the 0.1 to get it in SI system, that is equal to 10 raised to minus 3 Newton second per meter square. Okay, so we are coming again back to Newton's law of viscosity. So in Newton's law of viscosity, the velocity profile that we will get like this, it is a parabolic profile. The velocity is at the bottom, that the fluid layer which is touching at the plate, stationary plate, will have a zero velocity, and when increasing the top, velocity will increase, and after a particular height velocity will be same, the difference will be very less. So we can write Newton's law of viscosity as tau equal to mu into du by dy. So the incoming parts we will be dealing with this equation, because this is a very important equation. So the shear stress we can write it as force by area. So F by A equal to mu into du by dy. F is equal to mu in A into mu into du by dy. So we can find the force from the Newton's law of viscosity, that is shear force developed between the fluid layers. So this is a very important concept, shaft in the bearing problem. In GATE and other competitive exam, it is a very important problem. Normally this question is asked from Newton's law of viscosity. So understanding this problem will fetch you good marks. So what is the problem? Actually a shaft is placed in a bearing sleeve. The bearing sleeve is shown in the brown color and the shaft in the blue color, and there is a gap between the shaft and the bearing sleeve, that is denoted as dy in the golden color. That in that gap the fluid lubricant oil is filled to avoid the friction. So shaft is rotating at an rpm of n rpm, that is revolutions per minute, and the diameter of the shaft is d and the length of the sleeve is l. So in problems you may be asked to find out the shear force developed in this case, or the torque that is required for the torque that is developed or torque that is dissipating. So we have to supply that torque, and or the power that is dissipating, so that we have to give extra power to maintain the same speed. So we will find out it. F is equal to mu into A into du by dy. We know this equation. From this equation we can find the force. Mu is the dynamic viscosity, coefficient of dynamic viscosity. It will be given for the given oil, and A is the area. What is the surface area? So it is pi d into L. D is the outer diameter of the shaft, and pi d we will get the circumference multiplied by length. We will get the full contact area of the fluid film, because in a circular sleeve, circular shaft is there. So pi d and L in meter square. So you should consider the units. D should be in meter and L should be in meter, then only you will get in meter square. Then du is the, we need du is the velocity difference. Du we can find pi dn by 60, where pi we know 3.14, d is the diameter of the pipe, n is the rpm, revolutions per minute, by 60 to convert into rps. If the revolutions is given in rps, revolution per second, no need to divide with the 60, so you will get meter per second. So next dy, the difference between the thickness of the fluid film or the lubricant film, that will be given in the question, the clearance space. Okay, the difference in diameter between the shaft and the sleeve divided by 2. Okay, in some question the shaft diameter will be given and the sleeve diameter will be given, so the difference between them divided by 2. Okay, so from this equation we can find the force, but in some problems it will be given, it will be asked power loss. So power we know 2 pi nt by 60 watt. So 2 pi we know, n we know, T, torque that we require. Torque is equal to force into diameter divided by 2. That is force into radius. That is F into D by 2. So D is will be given in meters. That is the diameter of the shaft. So we can find the torque. Then from substituting in power equation, we can find the power also. I hope you understand the concept. So in this lecture, we discussed the concepts of Newton's law of viscosity, then Newton's law of viscosity, and a very important concept, that is shaft in the bearing problem. So I'm giving you a question. This was asked in GATE 2008. So a journal bearing has a shaft diameter of 40 mm and a length of 40 mm. The shaft is rotating at 20 radian per second. It is omega, and the viscosity of the lubricant is 20 millipascal second. The clearance is 0.02 mm. The loss of torque due to viscosity of the lubricant is approximately. So therefore there is 4 options. You can solve this problem. If you are not able to solve the problem, just watch the video again, that shaft in journal problem. So solve this problem. If you are getting the answer, please comment it. So I hope you understand. You can solve this problem. So I'm concluding this lecture. So if you like this video, please subscribe our channel and support us. Share our videos to your friends, and you can request for videos, and you can ask questions also. Thank you for watching.